Okay, in this video we're going to look at solving systems of equations with substitution. So let's consider the example 3x plus y equals 14 and y equals 4x. Now whenever we're solving a system of equations, okay, we're looking for when these two lines will intersect. When will these two tile patterns have the same number of tiles? When will these two trees be the same height? When will these two people have the same amount of money? This is what solving a system of equations is. Okay, and as we move through the year, we learn that equations can take different forms. Okay, but these are both still lines, and we still want to know where these two lines will intersect. And as we saw these different forms, we learned different techniques. Okay, and this technique, substitution, is used when it tells us what one of the variables equals. Okay, it tells us that y equals 4x. So we use this fact to help us solve the equation, because the first equation says 3x plus y equals 14, and the second equation says, well, y equals 4x. So what we do is we substitute this 4x in for this y. Because it's saying y equals 4x, that means every single y in this problem also equals 4x. So we substitute, and instead of having 3x plus y, we're going to have 3x plus 4x equals 14. We just replace this y in the first equation with what it equals. It equals 4x. So instead of doing 3x plus y, we're going to do 3x plus 4x equals 14. So now let's just simplify and solve. 3x plus 4x is simply 7x. So we have 7x equals 14. So I'm going to divide both sides by 7, and I get x equals 2. Because I know 7 times 2 equals 14. Now what this x equals 2 means is that figure 2, these two lines are going to have the same number of tiles, or we hope these two lines have the same number of tiles, or after 2 days these two people will have the same amount of money. Now all that's left is to figure out, well, how many tiles are in this figure 2? Okay, so we need to figure out what is y. If x equals 2, what's our y value? Because we have two variables in our equation, so we need both our x and our y as part of our answer. Well, we have all the information we need to figure it out. We know x equals 2 and y still equals 4x. So I know y equals 4x and x equals 2. So y equals 4 times 2. So y equals 8. Okay, so in this second rule, figure 2 has 8 tiles. Now just to be sure we did it correct, we're going to check our answer in the other rule. So in our first equation, we better also get y equals 8. We better also find that figure 2 has 8 tiles in this first equation. So we're going to do 3x plus y equals 14. We're checking in our first equation. So we know x still equals 2. So we do 3 times 2 plus y equals 14. Now this one's a little bit trickier because it's not as nice and neat as this one was, but we still go through our same steps. We're still substituting 2 in for x. 3 times 2 is 6. So we have 6 plus y equals 14. And we just solve this equation. Okay, 6 plus what number equals 14? Or we subtract 6 from both sides, and we also get y equals 8. Okay, and we're happy because these two numbers are the same. So for both of our equations, okay, when x equals 2, both our y's equal 8. Figure 2, they both have 8 tiles. After 2 days, they both have $8. These two lines will intersect at the point 2, 8. Okay, and that's how we solve a system of equations with substitution. Okay, so let's look at another example before you try some on your own. So let's say we have x minus 2y equals 11. And x equals 3y plus 1. Okay, now there's two things different about this equation, or this system of equations. We want to identify that we still have a line, okay, so we still want to know where these two lines intersect. Now this one is telling us what x equals, so we know we're going to use substitution because we know exactly what x equals. It tells us what x equals. X equals the expression 3y plus 1. So all we're going to do, just like we did in the example before, we're just going to substitute what we know x equals in for x in our first rule. Because x equals 3y plus 1, that means every single x in this system also equals, or sorry, x equals 3y plus 1. So every single x in the system also equals 3y plus 1. So we're going to substitute 3y plus 1 in for the x in our first equation. So we have 3y plus 1 minus 2y equals 11. Okay, everything else in this first equation stays exactly the same. The only thing that changed is we substituted 3y plus 1 in for this x. Okay, and these parentheses are just a group just showing that this 3y plus 1 replaced the x. We substituted 3y plus 1 in for the x because it told us, the second equation told us that's what x equals. Okay, so now let's just simplify. 3y minus 2y is 1y. We still have the plus 1 equals 11. So y equals 10, because 10 plus 1 equals 11, or we subtract 1 from both sides. Okay, that's great. So we know at some point both of these lines, or both of these tile patterns, are going to have 10 tiles. We just want to know which figure will that be. Okay, both of these people will have $10. We want to know when that's going to happen. So we got to go back and find our x value. So we know that x equals 3y plus 1. And now we know that y is 10, so we're just going to substitute 10 in for y. So x equals 3y plus 1, so x is going to equal 3 times 10 plus 1, because we want to know what value of x will get us y equals 10. 3 times 10 is 30, plus 1 is 31. So in our second rule, okay, figure 31 is going to have 10 tiles. So we better hope the same thing happens with our first equation. So we're going to check our work. So we have x minus 2y equals 11. Okay, y still equals 10. We still want to know when does this rule have 10 tiles. So we have x minus 2 times 10 equals 11. Well, 2 times 10 is 20, so x minus 20 equals 11. I'm going to add 20 to both sides to get rid of this minus 20, so x equals 31. That's exactly what we wanted. Okay, we're happy again because in both of our equations, when x equals 31, y equals 10. So these two lines will intersect at the point 31, 10. Okay, so why don't you try these two on your own. So when you see them both, press pause, try them both, and then press play when you're ready to check your work. So the first one, we have 2x plus y equals 28. We have y equals 2x. And for our second equation, let's say we have x plus 7y equals 36, and x equals y plus 4. Okay, so press pause, try solving both of these equations, then press play when you're ready to check your work. Okay, so the first one, we have 2x plus y equals 28. The second equation tells us that y equals 2x. So we're going to substitute 2x in for y in our first equation, because this means every single y in this system equals 2x. So this y in our first equation also equals 2x. So we have 2x plus 2x equals 28. And now we just simplify and solve. 2x plus 2x is 4x equals 28. So x equals 7. So we know that figure 7, these two are both going to have the same number of tiles. We just want to know how many tiles will they both have. So we have y equals 2x. So y equals 2 times 7. We just substitute 7 in for x. So y equals 14. Okay, so in our second equation, when x equals 7, y equals 14. So we better hope we get the same thing in our first equation. So we're going to check our work so we know we do it right. So x is still 7, so we're going to do 2 times 7. Plus y equals 28. So we have 14 plus y equals 28, and we subtract 14 from both sides. So we also get y equals 14. Okay, these are the same, which makes us happy because we know we did it right. So in both of these tile patterns, figure 7 have 14 tiles. These two lines will intersect at the point 7, 14. Okay, the second equation, we know that x equals y plus 4, so we're going to substitute y plus 4 in for the x in our first equation. So instead of having x plus 7y, we're going to have y plus 4 plus 7y equals 36. y plus 7y is 8y, so we have 8y plus 4 equals 36. 8y equals 32. I'm just subtracting 4 from both sides. That means y equals 4. Okay, so we know at some point both of these tile patterns are going to have 4 tiles. We just want to know when that's going to happen. So we want to know what's x. So x equals y plus 4. So x equals 4 plus 4 means x equals 8. So in our second equation, when y is 4, x is 8. So you better hope we get the same thing in the first one. So we have x plus 7y equals 36. We substitute 4 in for y again. X plus 7 times 4 equals 36. X plus 28 equals 36. Subtract 28 from both sides, and we get x equals 8. Okay, these are the same, so we're happy. Okay, in both of our equations, when x equals 8, y equals 4, these two lines will intersect at the point 8, 4. Great. So now let's look at some other examples where things get a little bit more complicated. But again, it's nothing we can't handle because we're taking it step by step and focusing on what we're doing. So let's say we have the system 3x plus 2y equals 27 and y equals 3x. Okay, so this is still substitution because the second equation tells us exactly what y equals. The only thing different here is that instead of having just one y like our previous examples, we have 2y. Okay, so we have 3x plus 2y equals 27. But we're still going to do the same thing. We're still going to substitute this 3x in for this y. Okay, so if we have 2 of our y's, that means we're just going to have 2 of our 3x's. Okay, so our first equation tells us we have 3x and 2y's equals 27. So instead of having 2y, or 2 of our y's, we're going to have 2 of our 3x's, or 2 times our 3x. So when we substitute, we have 3x plus 2 times 3x equals 27. Okay, we just substituted 3x in for this y, and instead of doing 2 times y, we're going to do 2 times 3x, because we have 2 of these y's, so that means we're going to have 2 of these 3x's. Okay, now we're just going to simplify and solve again. Okay, the first thing we do is multiply, so this 3x stays. 2 times 3x is 6x. 3x plus 6x is 9x equals 27. So x equals 3. Again, all we did was substitute 3x in for y. The only thing that was different here is we had 2 y's in this equation, which only means we have 2 of our 3x's. We solve, we get x equals 3, and we follow the same steps after this. Okay, we want to know, well, what's y when x equals 3? So we look at this one, y equals 3x. So y equals 3 times 3. So in our second equation, when x is 3, y is 9. We're going to check our work in the first equation just like we did before. Okay, the process doesn't change. Just because we see a little bit more complicated of an example, we're still doing the exact same thing. X is still 3, so we're going to do 3 times 3 plus 2y equals 27. 9 plus 2y equals 27. We just multiply. Now we subtract 9 from both sides and get 2y equals 18. And y equals 9. Okay, we're happy because these two are the same. So these two lines will intersect at the point 3, 9. Okay, let's look at another one. 5a minus b equals 9. And a equals 3b minus 1. Okay, now just because we change the letters doesn't mean we change what we do. Okay, just because we have a's and b's instead of x's and y's, the whole process when solving a system like this remains the same. The second equation tells us exactly what a equals, so we're going to substitute what a equals in for the a in our first equation. Now we're only substituting in for the a. The first equation tells us we have 5 a's. Okay, so we're going to have 5 of this group, 3b minus 1, because we're replacing this a with 3b minus 1. So we have 5 a's, that means we have 5 of this group. And we write that as 5 times the group 3b minus 1, because we have 5 of this group, minus this b equals 9 still. Okay, and now we just want to simplify and solve. If we have 5 of this group 3b minus 1, that means we have 5 of our 3b's and 5 of our minus 1's. We're just going to distribute. 5 times 3b is 15b, and 5 of our minus 1's will give us minus 5, because 5 times minus 1 is minus 5, minus b equals 9. Now let's just keep simplifying and solving. 15b minus b is 14b, minus 5 equals 9. I'm going to add 5 to both sides to get rid of this minus 5. So 14b equals 14. Divide by 14 and I get b equals 1. Okay, which is great. So I know when b equals 1, okay, a better equal the same number. So I'm going to substitute b equals 1 back in for b in both of my equations, just like we did before. So I know a equals 3b minus 1. So a is going to equal 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. So in my second equation, when b equals 1, a equals 2. So I better get the same thing in my first one. So I have 5a minus b equals 9. So I substitute 1 in for b. So 5a minus 1 equals 9. Add 1 to both sides. 5a equals 10. Divide by 5 and I get a equals 2. Now all we're doing here at the bottom is just finding the value of a and making sure it's the same. Okay, like I say all the time, it's better to take the extra time and get the problem right than get it wrong very quickly. Now in this part, we know a equals 2 and b equals 1. Now we write our answers a little bit different when we don't have x's and y's, because x's and y's are points to plot and our other variables aren't necessarily points to plot. So we're just going to write it as a equals 2 and b equals 1. Great, so again, I'm going to give you 2 examples. You're going to press pause, and you're going to try them on your own, then press play to check your work. So let's say we have 2x minus 5y equals negative 11, and x equals 8y, and 6r minus 2s equals 8, and s equals r minus 4. Okay, so press pause, try these on your own, then press play when you're ready to check your answers. Okay, our first one, we know that x equals 8y, so I'm going to substitute 8y in for x. So this tells us I have 2 x's, so I'm going to have 2 of my 8 y's. So I'm going to do 2 times 8y minus 5y equals negative 11. 2 times 8y is 16y, minus 5y equals negative 11. Subtract these, 11y equals negative 11. Divide, so I get y equals negative 1. So I'm going to go back and find what x equals. I know x equals 8 times y, so x is going to equal 8 times negative 1, which means x equals negative 8 in my second equation. So I'm going to double check with my first equation. So I have 2x minus 5 times negative 1 equals negative 11. Okay, negative 5 times negative 1 is positive 5, so this is going to be 2x plus 5 equals negative 11. I'm going to subtract 5 from both sides, or add negative 5 to both sides, get rid of the positive 5. So I have 2x equals negative 16. Divide by 2, get x equals negative 8. I'm happy because those are the same, so these two lines will intersect at the point negative 8, negative 1. Okay, in this example, again, we're not afraid of the different variables. Okay, we know we solve it the same way. Here, s equals r minus 4. So I'm going to substitute this group, r minus 4, in for this s. So I have 6r minus, well, since I had 2 s's, I'm going to have 2 of this group, r minus 4. This is going to equal 8. Now we have to be a little bit careful when we're doing this distribution, because we have this negative 2 that we're distributing, so we want to make sure we don't forget that. We're doing negative 2 times r is negative 2r. Negative 2 times negative 4 is positive 8, so this is plus 8, so we're doing negative 2 times negative 4, and that's plus 8 equals 8. 6r minus 2r is 4r, plus 8 equals 8. I'm going to subtract 8 from both sides. 4r equals 0. I'm going to do 0 divided by 4, so I get r equals 0. Okay, so when r equals 0, we want to go back and figure out, well, what does s equal? So we know that s equals r minus 4. So s is going to equal 0 minus 4. So it's going to equal negative 4. So when r equals 0, s equals negative 4 in our second line, or our second equation. In our first one, we have 6r minus 2s equals 8. R still equals 0, so we do 6 times 0 minus 2s equals 8. Okay, this is just 0, so we have negative 2s equals 8, which means s equals negative 4. Okay, we're happy because these are the same, so our answer is r equals 0, s equals negative 4. Okay, and that's how we solve systems using substitution. If we just look, it's very systematic, it's very step-by-step, but it's very important that we take the time to learn these steps and master these steps. So if you still need more examples, refer to the textbook or some of the online resources provided on the homework hotline.